Are you prepared to witness the technologies that will redefine our world before 2027? From autonomous robots that move and think like humans, to colossal machines lifting cargo where roads don't exist, and vehicles that recharge as they drive, these innovations are pushing the limits of imagination and engineering. Today, we're diving into the most groundbreaking inventions that aren't just ideas. They're real, tangible breakthroughs shaping the next decade. Every device, every machine, every system in this video is designed to amaze, inspire, and show you the future as it's happening right now. Onero H1 from SwitchBot is a versatile AI-powered household robot that pushes beyond single-purpose gadgets into a general-purpose home assistant built to handle a wide range of everyday tasks with embodied intelligence and adaptive perception. Rather than being restricted to one job, it is designed to learn and respond to diverse domestic scenarios with real-time visual, depth, and tactile feedback that helps it understand object position, shape, and interaction states, a capability that many simpler robots still struggle with. The robot moves on a stable wheeled base and incorporates 22 degrees of freedom, giving its articulated arms and hands the flexibility needed to grasp, push, open, and organize objects throughout the home. At its core is an on-device OmniSense vision-language-action model, which fuses visual perception, depth awareness, and tactile sensing so that Onero H1 can adapt across tasks and environments without being locked into a fixed routine and without relying solely on cloud connectivity for decision-making. Onero H1 is designed to work in harmony with SwitchBot's broader Smart Home 2.0 ecosystem, allowing it to coordinate its activity with other smart devices like robot vacuums, locks, and environmental sensors to amplify overall home automation rather than operate in isolation. Vibot Agent Robot emerges as an intelligent autonomous home assistant built to feel more like a presence than a machine, translating everyday commands into purposeful action and redefining what a personal robotic companion can be. Also known commercially as VBot Intelligent Companion Robot, it is designed to operate independently throughout living spaces while interacting with users in a natural, intuitive way, making assistance feel immediate and human-centric. The core of Vibot's interaction model is Vision-Language-Action Intelligence, a system that links natural speech directly to movement and decisions, so spoken commands become real-world actions without awkward technical prompts or rigid commands. This approach lets it interpret context, respond to conversational cues, and adjust behavior based on what it senses and learns in a given environment. Vibot navigates freely around the home using advanced visual perception and onboard sensors that recognize rooms, objects, and people in real time. This spatial awareness eliminates the need for predefined paths, letting it move smoothly around furniture, hallways, and doorways while avoiding obstacles and repositioning itself precisely for every task. Its motorized mobility system gives it practical usefulness beyond simple movement. Vibot can carry bags, fetch items, follow users from room to room, and hold position where needed to assist with daily routines. Anti-Gravity A1 8K 360. Drone is built for creators who want the sky to feel limitless and the aircraft to practically vanish from the shot. This drone flips the script by turning flight into a pure cinematic viewpoint, capturing everything around it in seamless 8,000 pixel resolution where the drone itself disappears. It is lightweight enough to slide under typical 250-gram limits in many regions, yet powerful enough to deliver visuals that usually belong to a much bigger rig. This drone weighs about 0.54 pounds with its standard battery, but inside that compact frame sits a dual 1/1.28-inch sensor system built for true spherical 8,000-pixel video and panoramic stills. Both sensors work together to record every direction at once, while advanced internal processing wipes out the drone body and propellers from the view. What you get is perspective that feels like a floating camera drifting through space with no hardware in sight. Control feels natural and instinctive. A handheld motion grip pairs with vision goggles using micro OLED displays and head tracking, so the drone follows your point of view as you look around. You simply move your head to frame a shot, while the aircraft keeps itself stable, smooth, and balanced. Even with its small size, performance hits above its class. Flight time reaches up to 39 minutes with a high-capacity battery. Ideal conditions give you up to 14.3 miles of transmission range, and top speed climbs to about 36 miles per hour. Forward and downward vision sensors add basic obstacle detection for safer low altitude and forward movement. If you are chasing the next evolution of aerial filmmaking, this is the kind of tech that changes the way you see the sky. MagRail by Nevomo is a magnetic rail technology engineered to unleash high-speed, low-friction travel on existing rail corridors without tearing up ground or building dedicated infrastructure from scratch. It uses passive magnetic levitation and electromagnetic linear propulsion mounted onto conventional rail lines, so trains can float above the rails with minimal contact, dramatically reducing friction and mechanical wear over long distances. Instead of traditional wheels bearing the load, MagRail vehicles lift using magnetic forces that hover above the existing tracks, while still using wheels for starting, stopping, navigating switches, and accessing stations. This compatibility means current rail networks can evolve into high-performance corridors without replacing the rails or rolling stock entirely. On a 700-meter-plus full-scale test track in Nowa Sarzyna, Poland, Nevomo demonstrated that MagRail vehicles can levitate above standard tracks, reaching stable magnetic levitation at speeds of about 85 miles per hour and accelerating from 0 to 62 miles per hour in roughly 11 seconds while maintaining precise alignment and controlled magnetic guidance. The ultimate goal of MagRail is to enable passenger service speeds up to 340 miles per hour on legacy rail lines, transforming regional and intercity travel by significantly cutting journey times compared with conventional rail. It does this without extensive civil works or new elevated tracks. Verge TS Pro is a breakthrough electric superbike that reimagines sport riding by blending radical engineering, exceptional range, and high-performance dynamics into one machine. At the heart of its design is a hubless rear-wheel motor, built directly into the rear wheel to eliminate chains, belts, and traditional drivetrain components, while delivering instant force to the pavement. The electric motor delivers up to 1,000 Newton-meters of torque, roughly 737 pound-feet, giving the bike explosive acceleration that can sprint from 0 to 60 miles per hour in about 3.5 seconds. Its top speed is around 124 miles per hour, and the instant torque feel, smooth, silent, and continuous, defines a new standard for motorcycle performance. Energy comes from a solid-state battery platform developed with Donut Lab. Available in multiple capacities such as 20.2 kilowatt-hours, or a larger pack that extends range to about 370 miles on a single charge in optimal conditions. The TS Pro supports ultra-fast DC charging, adding roughly 186 miles of range in about 10 minutes, using up to 200 kilowatts of power, making long rides practical instead of theoretical. DLR Maya. Assistive Robot is a pioneering assistive system developed by the German Aerospace Center that brings advanced robotics directly into daily life for people with severe motor impairments by integrating a mobile robotic arm with a powered wheelchair, so users can perform everyday tasks with greater independence and confidence. The heart of Maya is a 7-axis robotic arm with 13 total degrees of freedom when combined with wheelchair motion, giving it a working reach of about 51 inches and the ability to interact with objects from floor level up to roughly 78 inches high. Equipped with safety-certified joint modules and Cartesian impedance control, the arm moves smoothly and safely around people and fragile items, letting users pick up objects, fetch items from shelves, open doors, and complete other everyday routines that would otherwise require assistance. Mounted directly to the wheelchair frame, Maya's compact design lets the arms stow neatly at the side when not in use, while its intuitive control system interprets subtle user input so movement feels natural and responsive. The entire platform weighs around 460 pounds, including the wheelchair, and the arm itself weighs about 31 pounds with a battery that delivers up to 6 hours of operating time between charges. Maya's base travels at roughly 3.6 miles per hour, giving it the mobility needed to move through typical indoor environments while maintaining stability and control. G1 is a fully bipedal humanoid robotics platform engineered to make advanced robotics more accessible for education, research, prototyping, and early commercial work, built around realistic mobility and a modular design that scales with user needs. Standing about 4 feet 4 inches tall and weighing roughly 77 pounds, the G1 platform delivers human-like balance, fluid walking, bending, and complex dynamic movements that mirror natural human motion while advancing hands-on learning and experimentation in robotics. Equipped with 23 to 43 degrees of freedom depending on configuration, it supports a wide range of articulated motion across its legs, waist, arms, and optional dexterous hands, enabling fluid locomotion and manipulation tasks that go well beyond simple pre-programmed moves. G1's sensor suite includes high-resolution 3-dimensional LiDAR and depth cameras that let it map and perceive its environment in real time, supporting intelligent navigation, object detection, and adaptive behavior. A 9,000 mAh lithium smart battery provides up to 2 hours of continuous runtime per charge, and the robot's lightweight aluminum frame with engineering plastics ensures durability and agile motion across controlled indoor environments. Singapore Industrial District Cooling System is a centralized, high-efficiency cooling network designed to maintain stable indoor temperatures across an entire industrial district, while drastically reducing energy consumption. Installed in one of Singapore's major technology parks, the system delivers chilled water through underground distribution pipelines to multiple factories, offices, and research facilities, replacing thousands of individual air conditioning units with a single intelligent infrastructure. The network produces cooling capacity equivalent to tens of thousands of household air conditioners, while consuming roughly 20% less electricity than conventional building-level systems, translating into significant operational savings and reduced demand on the electrical grid. By centralizing cooling generation, the system also prevents over 100,000 tons of carbon dioxide emissions annually, substantially lowering the environmental footprint of industrial operations. In addition to energy efficiency, the design frees rooftop space from bulky cooling equipment, creating opportunities for solar panel installation and green infrastructure, further enhancing sustainability. Real-time monitoring and intelligent control allow the system to optimize cooling delivery according to demand, ensuring comfort without unnecessary energy use. By scaling climate control to the district level, Singapore's industrial cooling system demonstrates a model for smart, sustainable urban infrastructure, proving that cities can maintain comfort and operational efficiency while minimizing their environmental impact. Extropic AI Thermodynamic Computing is a next-generation computing platform that leverages thermodynamic principles to process information probabilistically, redefining how machines handle complex tasks. Unlike traditional binary processors, Extropic's hardware uses thermodynamic sampling units where natural thermal fluctuations drive computation, allowing probabilistic bits to explore solution spaces efficiently for optimization, machine learning, and physics-based simulations. This approach aligns computation with the laws of thermodynamics, turning thermal noise and energy fluctuations from a limiting factor into a computational resource. By doing so, the system achieves dramatically higher energy efficiency compared to conventional graphics processors, reducing heat output while maximizing useful computational work. Extropic's architecture excels at handling probabilistic AI workloads, such as inference and optimization tasks, where conventional deterministic processors struggle with speed or energy cost. By allowing bits to naturally fluctuate and sample multiple states simultaneously, it can converge on solutions faster, supporting scalable, low-energy artificial intelligence systems suitable for edge deployments, high-performance scientific simulations, and energy-constrained environments. Adaptive hydrogels are a class of smart materials made of highly water-rich, flexible polymer networks that behave more like living systems than static plastics or rubbers. Their polymer chains hold large amounts of water inside a three-dimensional mesh, giving them softness, stretchability, and an innate ability to interact with their environment in ways traditional materials cannot. What sets adaptive hydrogels apart from simple gels is their stimuli-responsive behavior. Many of these materials change their physical or chemical properties when exposed to temperature changes, shifts in pH, light, electrical fields, or specific chemicals. In response, they can swell, shrink, stiffen, or release embedded substances on command, effectively translating external cues into predictable material changes. In medicine, this adaptability has powerful implications. Hydrogels can mimic the softness and moisture of natural tissues to support wound healing, act as controlled drug release systems that deliver therapeutics only when and where needed, or serve as scaffolds that guide tissue regeneration with water-like compatibility. Their high biocompatibility and ability to change with the body's physiological cues make them invaluable in wound care and regenerative therapies. Some hydrogels are self-healing, meaning they can repair microscopic damage on their own by reforming dynamic bonds in their network without external input, and others can modulate stiffness to guide cell behavior during healing or growth processes. Mojo Vision's smart contact lenses are redefining the very way we see the world, turning human vision into a seamless digital interface without the need for screens, glasses, or external devices. These transparent lenses integrate a microscopic display capable of projecting real-time information directly into the wearer's field of view, perfectly aligned with natural eye movement. Advanced built-in sensors track eye motion with extreme precision, keeping digital content stable and readable no matter where you look. This creates a fluid, uninterrupted blend between the real world and augmented overlays. The lenses can deliver essential information such as navigation cues, health metrics, notifications, and contextual data, helping you stay informed without distraction. Every component, from micro-scale processing to power systems, is designed for comfort, safety, and extended wear while preserving visual clarity. By embedding augmented reality directly into the human eye, Mojo Vision pushes beyond devices, moving us toward a future where vision itself becomes the interface. That's a glimpse into the future of innovation, and we've only scratched the surface of what's coming before 2027. Which invention blew your mind the most? Drop a comment below and let us know. Don't forget to hit like if you were amazed, share this video with friends who love cutting-edge tech, and subscribe for more exclusive looks at the machines and ideas shaping tomorrow. The future is moving fast. Make sure you don't miss a single breakthrough.